So welcome. Thank you very much for coming. I'm Erin Moore, assistant professor in the Department of Architecture, as you know. And on behalf of the Lecture and Exhibits Committee, I am thrilled to welcome Lisa Pedersen and Walker Templeton from SERA Architects in Portland to talk about the EMU, the Memorial Union project. And I'm thrilled to be able to say that between the two of them, they have at least 3 degrees, maybe 4 from the University of Oregon. Walker has a Master's of Architecture from here, Portland, actually the Portland program, a Bachelor of Arts in Multimedia Design and Business, I think, also from here. And Lisa Pedersen is also a graduate of the architecture program. So would you join me in welcoming Lisa Pedersen and Walker Templeton? So you get this one.
Lisa's going to take the mic, and I'm going to just project because I speak fairly loud, and with the mic I tend to be too loud. So presentation is on creating the center of campus, and it concentrates on the idea of working with large user groups and this integrated sustainable design. And I'm going to quickly, I know that we introduced Lisa, but I want to reintroduce you, Lisa, just because Lisa was a huge factor in my coming to SERA. She heads up our sustainable resource group. 12 people? 10 people? 10 people now.
A couple left.
And so you always get this idea as a designer that it's great to get metrics, to get numbers, but generally with my ADD, it doesn't come quick enough. And Lisa has convinced me through the years now to hold off, keep my pen off the paper for a little bit while she gathers the metrics, while she gathers the data. And with the resources she has, it comes fairly quickly. And then you'll see as we go, as we give the presentation here, it's a hand in hand, it's a back and forth. I can skip something and I can have results the next day. So it really helps with the process.
So I just wanted to say that what we wanted to share really was how design integrates with sustainability and becomes one thing that's stronger because of the two of us than just the single thing. So thanks, Walker.
And it really is less of a lecture and more of a conversation, and so feel free to ask questions at any time. When Lisa starts talking the way she talks, sometimes I'm like, huh? So if you need her to slow down or to say what some of the things mean, feel free to raise your hand, have a conversation.
Absolutely. So a little background on SERA Architects. SERA was formed in 1968. Bing Sheldon, the S in SERA, formed what he called the Design Collaborative. And really that started this whole idea of a collaborative practice. Don Eggleston joined him in 1972, which was actually joined for the EMU project. The 1970s wing was Don Eggleston's first project at SERA. So very ironic now that what we're going to be talking to you about today. We are 86 employees, over 50% lead AP, and we're also 100% ESOPed. So we're a 100% employee-owned company. These are some of the projects that we're working on right now. The Collaborative Life Sciences building, the top image, is in the South Water Park in Portland. It's a new classroom, research, dental clinic lab for the Oregon Health Sciences University, along with Portland State University, as well as the OUS system in general. The Oregon Sustainability Center here is a project that we designed meeting the Living Building Challenge, and the Edith Green Wendell-Wyatt project that just opened this past summer, a LEED Platinum high-rise that's projected to be meeting the 2030 challenge.
And we'll quickly go over a couple of these in the slides just to sort of warm up. It was actually kind of a progression for our firm on how to do the sustainable, integrated sustainable design. So we're going to quickly hit a couple of these projects on the way to EMU. Quickly about our office. We are located in downtown. It's very old town downtown, and that was done on purpose. We wanted to locate there to reinvigorate the streets. It's sometimes coming out of the office at 4 o'clock in the morning. It's still a little scary sometimes, but Lisa knows more about the lead. I know that downstairs, this was before I got there, I know that the downstairs we did
LEED Gold and upstairs
and
light.
upstairs platinum. By the time we finished downstairs, we were already too big and had to punch a hole and go upstairs and take over the upstairs. I would say part of what I brought to the firm was when I joined, I said I have to have a model shop and I have to have a chop shop. And within the first 6 months, we have it. Now, because a lot of the stuff I like to do is with models. I like to see it full scale, mock-ups. They're quick, they're down, they're dirty, but I really think it's important for us as the architects to study those, and then I use them a lot in presentations to the client. And we also try to figure out, you'll see in the presentation, ways of using physical objects to work with a large user group.
Another important aspect of our firm is our commitment to the Architecture 2030 Challenge. And so we've been tracking our metrics since 2010. And basically we look at not only the predicted EUI, but also lighting power density, and use project energy modeling to help us to understand how we can position our projects. And that's particularly important as you start to look at how you can go about meeting the Architecture 2030 Challenge. So this graphic is our 2010, and what you see on the y-axis is how close a project is to meeting the net zero requirement. If it's 100%, it means it's meeting the net zero requirement, or it's a net zero project. The EUI is actually what's on the x-axis, and so depending on the project type, the EUI would vary because, of course, what you're doing with the 2030 Challenge is you're comparing to the building that's a typical building for that particular building type. And what you see is SERA'S average with a net zero project at 58% is barely just about at the 2030 Challenge at that time at 60%. It's a tough challenge, and I know the University of Oregon has signed on to the 2030 Challenge, so I wanted to let you all know that as we're tracking this, it's tough, but we're out there trying to make it better, to make sure that we see how we can achieve it as we go along.
Quickly, this is a project downtown Portland. I was not involved with it. It was before I came to SERA, but it was with Cutler. But Lisa had a big involvement with this. But I just would say, after meeting with Cutler, after talking with the project team, it was very important that the building emotionally portrayed sustainability. They tried to really evoke that emotion, and the reason I bring that up is we'll talk about this later on in the presentation, is what I try to get out of a client working with a large group of people is to get the touch, taste, and feel, the emotion of the project. If we could get that, if we could communicate together on that level, then I think then the architecture starts to fall in place. So I was very impressed with this building.
So one of the important aspects that Jim really wanted to emphasize was to maintain the existing building character as we created this new high-performance high-rise. And so as you go inside, the old concrete beams were retained, even though we punched holes in them to allow natural light to go down to the main conferencing floor. And so it was this kind of juxtaposition of the new and the old as we went through the entire design process. And one of the important things that we looked at, and the reason that Walker and I wanted to do this together, is the idea of design and metrics working hand in hand. And so we first came up and looked at a series of daylight analysis and shading analysis to come up with some potential schemes that could work and meet the goals of the project, which we needed to meet the ERA legislation requirements, which essentially are in line with the Architecture 2030 requirements. But then Jim went about sketching in the same way that Walker's doing, and it's this hand-in-glove idea, and then we think that makes design better.
Same thing with the Oregon Stainless Center. This was on a very tight site. Basically, the site dictated the shape of the building, how they're going to get to net zero. Again, Lisa could talk more about that, but I think the beauty in this building is the fact that it was formed from the metrics.
And one of the things I always like to talk about, I didn't even know John was going to be here, and I put in my favorite slide, is that we as architects can't do the design alone. We need to also rely on the building occupants. So what this is looking at is how do you go about achieving net zero energy. So the energy pie on the far end is the typical building. We always start with what is the uses divide up in terms of the energy pie. And then as we start to look at all of the ECS strategies that you've heard about in your class, natural ventilation, passive cooling, passive heating, solar, photovoltaics even. And we still can only get so far towards a net zero building. And particularly with the Oregon Sustainability Center, with its very tight site, we needed to go even lower. And so we asked the building occupants, would they be willing to impart some different strategies, what we called occupant engagement, to further reduce the overall energy. And much actually to our surprise at the time, they said, yes, we would like to employ things like having the janitors come in during the business day so that we don't have to have that extra half an hour of lights or 2 hours of lights as the cleaning staff. No, we don't need super hot water in our bathrooms. And yes, we actually are willing to import different kind of computing technology to bring down our overall goal. And with the occupant engagement strategies, using stairs instead of elevators, we were able to achieve the overall goal of the Oregon Sustainability Center on site with PV. And then that PV turned out to be what we needed in terms of the overall collection of rainwater. And so what this diagram is really showing you is the parts and pieces of the overall rainwater or net zero water collection strategy. But I wanted to point out how the hand in glove of the photovoltaic array and the water system became jointly. And we're always looking for what we call a twofer or a threefer. How can you have one thing that does more than just its single solitary purpose? Is there another purpose? And that's another theme that you're going to see as we talk about the EMU project.
So quickly, a little history on the EMU. I'm sure everyone here knows more about it than I do, maybe. But I did do quite a bit of research on it. I thought it was very interesting that it started off, it wasn't Ellis Lawrence. It was the last building he worked on. It took almost 15 years from the time he started sketching it to the time it started to get built. So it was taken over by his son. And I think that might be some of the reasons why it might look a little different than the other Ellis buildings. It's the most, I guess you could say, modern building on campus. It's a little bit more austere, a little bit more minimal, but as you'll see when we'll go through some of the analysis that we did on the building, and you can see that there's actually a lot going on in this building. It did a lot for the time. So a couple of challenges we had while we were looking at this building was, if you go back to the original context, I love this image of the building. In the original university, it was very set up. It sort of on purpose kind of got away from 13th a little bit, because really at the beginning that was all cars. So this was very car-centric, and there was a lot of pedestrian access was actually in the north-south, and it had a very lineal, progressive. It lined up with all the axes on campus, and it had a very formal front and back. You would drive up to this main set of stairs. So now that times have changed, and we're trying to really activate this street with people and not cars, well, that's some of the challenges that we had with this building. The 70s building, we looked at it. We tried to do some analysis on how we could possibly save it, but it had very short floor-to-floor ceiling heights, and it was very inefficient. But I do have a little story to tell why it was a little inefficient, because we had a little bit of insight, because it's what started SERA Architects. And according to Bing Sheldon, it was built that way because someone in line got stabbed while waiting for food. At the cafeteria. So they said, well, what can we do to maybe break up some of these lines that are starting to come out the door, down the street? What can we do? And so the idea was, okay, let's put food up top, and let's make it a maze to get up there. So there's multiple ways to get up there. And so, there's always a reason to do things, why they did things when they did it. And there was also an addition in the 60s that's right now the fountain court. And so you'll see in the design, we tried to use the 60s, and we just could not use the 70s building. I'll just quickly run through these because I think everyone here knows. But one thing I would point out is we do student unions across the nation, and one thing that a lot of colleges and universities across the nation would kill for, is that this thing is in the geographical center of campus. So it's already got a lot going for it. When we work on other campuses, we're trying to, if you say located over here, we're trying to pull students to it. But right now, currently, students walk right underneath the thing. They walk around it. Next slide. Lot of bicycle traffic. Currently, there is some bicycle traffic that goes under the building. It's actually not supposed to do that, so we are going to do a couple things to reinforce where bicycles are supposed to go. Some public transportation nearby, which opens up to then the cars. So this is what we were talking about earlier. Is we still have some car routes here. You'll see as we progress here that maybe we'll do a little something to cut some of the car traffic off and give this back to the students. A major note on campus, it's directly located. Another thing that a lot of campuses will kill for is that it's right next to the major crossroads on campus, 13th and University. If you ask anybody where center of campus is, it's 13th and University. If you ask them where the student union is right now, I bet you a lot of people wouldn't even know. I come here every week, and it happens almost every single week. I'm standing right here, looking at the building, talking to our fellow architects. I'll have someone come up and they'll say, "Do you know where the EMU is?" And I got a point. It's right there, but it's 75 feet back from the road right now. 75 feet, and there's 2 layers of trees in front of it. So you'll see when we go through, we did a couple things to try to fix that problem. Up close, the reason I just wanted to quickly blow this up is that there also only a few places on campus have parking. This building has parking as well, so there really is no back door to this building, and we have to deal with some of the issues like trying to keep and maintain some of that parking that's here because it's vital for the conferencing that goes on in this building. And I want to point out again that right now people go under this building, and so if we go to the next slide. So this is what the big idea of the building was to try to, and at the time we didn't really know how, but we said, okay, how can we take this building and get people to go in it? Even if they walk through it for 5 minutes, grab a cup of coffee, read the paper, I think that we've achieved our goal. We get more people in the student union. And so someone in the user group said a leaky building, not in terms of performance, but in terms of having a few front doors of this. And so the idea is to start to capture some of this traffic that goes in. You'll see ahead, you're coming into this historic, right now you go under the building, and what we're saying is very light intervention because this is the most historic facade in the building. Maybe we just do just a set of glass doors, and now you come in, and we'll show you later that you'll come in and you'll come into a double height space, a new hearth on campus. Next slide. Another big idea was pushing this building north, getting it closer to the road. We went from 75 feet to 35 feet from the road. We've actually now increased our south lawn. This was very important to us to get actually more green to the south and less hardscape on the north. This is now going to be one of the largest south-facing lawns on campus. The design is set up for graduation, for events. A lot of it is key around the south lawn. And another thing you'll notice is the multiple entries. A big concept is to get everything down to ground floor. I'll go over that here in a little bit.
So another important influence for the project was, of course, the pattern language. This is University of Oregon, so you need to involve the pattern language. So starting out the process, we went through and remembered all of our history of being students here and looked at the patterns. We ended up selecting these 10 as being important patterns for us, and not surprisingly, things like being at the hub of campus, that's a great pattern for a student union, having a few front doors, we talked about that, how the leaky building idea, the kitchen great room, I mean, who doesn't want to have the I Love Lucy set up? Light attracts use, that's a really important pattern for a student union, really one of the overall prime goals. And really, that was something that we arrived at early on in the design process of really how could we link these patterns together to come up with a partie that really could describe the essence of this particular building.
So going into it, now we're going to start talking about working with the user group. We actually had these before we worked with the user group. We came up with, and then we were asked to come up with the patterns that you think are useful for this building and how that can generate some sort of an idea for the building. And so this is the exact partie we used. It was just this idea, again, of creating some sort of park, some sort of great room that had multiple areas to bring students in through the building. And so armed with the patterns, armed with this partie, a lot of analysis on the building, we were able to then meet with the clients, create goals, and some of the design drivers, so this was day one, this was the very first meeting, was recruiting students, timeless, multifunctional. We kept going back to this timeless. We wanted it to be of today, but not, we wanted to meld with the building that's next to it. Simple, enduring, not tech-based. I thought that was pretty interesting, that we're trying to come up with sort of a bomb-proof building. Simplicity.
So sustainability has been an important driver for the project really from day one. The user group brought some of that, which you can see with their highest hopes and greatest fears. That was the list that you just saw. We also were the first project that was under the Oregon Model for Sustainability, which was adopted in July of 2011. So energy, making sure that we don't increase the overall campus energy was one of the goals of the project. Managing stormwater and making sure that we manage the dirtiest water first was another important pattern. And then people, making sure that we engage the people and we engage especially the students in understanding the sustainability and how they're going to be saving the energy and water in the building. So those were really the three overarching goals, but we also wanted to make sure that we brought some of these other elements. And we started, with a brainstorming session where we really came up with these sort of three taglines of what we really wanted the building to be. We wanted to make sure that it uses the resources in the right way. We wanted to make sure that it's elegantly green, that it communicates to the students and the faculty what it's about, and that it strengthens and inspires the community. So these were really the overarching goals. But one of the things that we like to do, and it came really from both the Oregon Sustainability Center and the EDITH Green Project, was to have specific metrics that we could use to check back with the design team about. So if you have a specific goal, you are either meeting that particular goal or you're not. So we looked at these characteristics or these categories and we created specific goals. For example, in energy, our minimum goal was the Oregon model, which turns out to be 35% better than the typical standard. But we had a stretch goal of being 45% better, and we were going to do that by engaging occupants in this 10 to 15% additional energy savings. We had specific goals around design process that the union needed to inspire its occupants, and around equity as well, and making sure that our building actually didn't adversely affect any of the other buildings surrounding it by blocking any of their light or air. So all of these together are part of our goals for the project, and we track them for each different deliverable and say, how are we doing on those particular projects? Now, one you can see fell off was our solar thermal goal. The light gray are ones that we're no longer pursuing. And it turned out for solar thermal, in the case of the kitchens, are located in the older part of the building, and we're keeping them there. The roof isn't strong enough to support the weight of solar thermal. And we also found out that we would be able to use the steam tunnel reheat, which we thought at the time the rec center was going to use and we weren't going to be able to use. So we're able to heat the hot water in a different way. So we said, okay, that goal, we all agree, is no longer part of our project. And similarly with the FSC wood, we found a better source of wood, which we'll talk about a little later. The other thing we do with all projects is start by understanding the climate. And the important thing that we look at is understanding how the temperature range fits on an overlay of what is a comfort zone. And so the orange band is the average daily temperature in Eugene, with the dotted red line, the high temperature, and the dotted blue line, the low temperature. And by overlaying the comfort zone, we talk about how often is it already comfortable enough outside that we don't need to do something inside. I actually had an email from the campus planning today talking about our student street and how many hours of the year, 85, is it going to be above that comfort zone? And is that okay? And when are those hours? And is it okay to be above that temperature, or do we actually need to provide cooling to make sure we go into the comfort zone? And, you know, different people can disagree, but maybe it's okay to wear shorts on those days. Who knows?
I guess I'm tough. I'm pushing for to keep the student street. we could cool with fans.
So as we go through, the design process that we follow would be to look at the climate, understanding the base building loads, understanding how our building compares to the 2030 challenge or other goals, look at load reduction through passive strategies like natural daylighting and passive ventilation, address the building envelope because that's a part of the building that's going to be there for a long time. And then we start to look at the mechanical systems, looking at making sure that they're right size, that we have dual use, we incorporate heat recovery. And then, of course, this idea of occupant engagement. That's something we want to bring to all projects because if the people are really the users of energy and anything we can do to help to reduce energy load from the people is something that we want to do. Oops.
So quickly with the scheme, we thought about this for a few weeks as a firm, and what I'm showing, I don't think we reinvented the wheel by any means, but I am going to show the techniques that we used, and they were very well thought out, and they were geared towards working with a large group of people. We knew we were going to be working with a large group of people. We weren't quite sure how large, and it was, 20, 30 people is the core group, and then we have other groups.
Well, and then we had students who would come in and out depending on the meetings. So it could be 50, 100 people depending on.
We wanted some way to physically show the building on the site, and what we came up with was this idea of color coding the blocks for program, and then putting it on a site with a piece of plexi underneath it that I could physically draw on while we were talking, to start thinking of paths, start thinking of other, maybe there was program space, maybe there's some other space that hadn't been thought about in the program, and that was kind of some stuff that I could sketch on the plexi itself. Excuse me. So we're just going to show a little bit of example of some of the students talking about it, but you can see the different pieces of the program. What I thought was great is you put, it's a great way to show everyone wants to be on the ground floor. But once you put all that program out, you can start to see that it needs to come up and people need to be on different floors.
In the middle, that goes down to the first floor where all the seating is, and then the skylight above that is seating. Yeah, so all of the seating is going to be down here, with this being the area that's going to.
We also introduced with these blocks the idea of energy programming. And so each of these are color-coded according to the program, like things together. All of the food service is one color, all of the student unions are a different color. But we added these additional dots to indicate whether the space wanted daylight. It had a yellow dot. If it didn't want daylight, it got a gray or a black dot, depending on the need for daylight. We also looked at the heat capacity and whether the space would be rejecting heat or needing heat, and color-coded those in a red, yellow, orange scenario. We looked at the times of use for those particular spaces, and we had people first group them based on their typical programming, and then we said, well, you've got a yellow dot in the middle of your overall block. How's that going to work from a daylighting perspective? Is there another way that you could do that, which would get all of the yellow dots, for example, on the exterior? And it was a really easy way for people to communicate and see not only are they developing the adjacencies that they want from a true programmatic perspective, but also from the idea of energy as well.
So from that, we were able to come in one or two meetings. I can't remember which one.
Well, we did the first schemes in 4 schemes in one meeting, and then got to the single scheme.
In the very first meeting, we hunkered down, spent all day, and were able to get these 20 or 30 people in the room. We took the blocks and we would arrange them on site, and as you can see, I would start to draw, like I said, that soft space, or maybe some other parts of the program that were not thought of originally would get drawn on, but we were quickly able to come down to 4 schemes, and I'll just to quickly walk through them. We'll go through them, but one was sort of a double-loaded atrium. Scheme A, we're just giving them letters right now. Scheme B was, again, more of a double-loaded, but it was in a different orientation, more of the north-south, and we'll go through and we graded all these sustainably as well. And then Scheme C, this one sort of quickly, we lost it because it was At the time, we had a performance hall, and it didn't allow for good access. We had the performance hall on the backside, and it didn't allow for good access to the performance hall, so that one was dropped. We've since lost the performance hall, but at the time, that one was dropped. And then Scheme D was more of a single-loaded atrium facing south student wing with the, we would try to locate as many programs that were appropriate for the 1950 building in the 1950 building. So part of this thing that I was talking about, emotion, trying to get emotion from the user group, was we took those 4 schemes back, we stayed in the office for the week, and we tried to come up quick. These are not precious. Everything we do is try to not be precious. Instead, what we wanted was emotion. We wanted to just convey, these are not within inches. These are sort of thumb up in the air. This is about the right square footage. This is about how this would fill it out on the site. So this is that idea of that double-loaded atrium, Scheme A, and just to quickly give visuals of everything we're at. That's why we use these large graphics, and we started to incorporate where some of the circulation would be. Scheme B, again, didn't work so well because the Performing Arts Center, we said we would probably have to come off the back, and this would create parking back here, and there was a lot of issues with this, but this was something that the user group came up with, so we diagrammed it out, and this was one that we quickly lost. Scheme C, same thing. We diagrammed it. We wanted to show what the user group had come up with, but again, we sort of decided, because of the performance hall, that this was probably not a go. Scheme D was this single-loaded atrium, south-facing, with a student bar facing north. I would say that one of the original schemes was to actually take the Mill Center chunk completely off and do all new student bar facing 13th, but that was we ended up not doing that.
So at the same time as Walker and the team are coming up with the diagrams, we're going through and testing them so that we can give the user group real-time information. So we do quick massing shading analysis so that we can understand not only what the building's potential is for solar and for daylight, but also is it going to be negatively impacting any of its neighbors. We also run shoebox energy modeling, and we specifically looked at 6 things. The top one is how good would the scheme be for adjacency for heat recovery distribution? How well are the spaces aligned? What is the skin to volume ratio, which has a direct effect on how your performance, the cross ventilation potential of the scheme, the radiant heating and cooling potential, solar opportunity, and daylighting potential. And quickly read this diagram. The greener it is, the better, because we're grading the schemes, and if you got a 1, then you're all the way green. And so as you see, Scheme A had the most green, and Scheme B was really, C and D were second. But one of the interesting things was Scheme D had the top rating in 2 of the most important criteria, the potential for daylighting and the potential for cross-ventilation. And so the user group was very interested in Scheme D, but wanted us to learn from Scheme A. And so we ended up with really an amalgamation of Scheme A and Scheme D. And I think one of the successes of why we were able to so quickly arrive at a specific scheme was being able to, at the same time as we're giving them information about the programming and how the building is, we're also giving them real-time information on the sustainability elements of the overall design.
Once that was determined, once we had a couple of schemes, that's when we started to do a lot of work in model. And I chose to show more of the finished model, but there were many, many, many iterations before this. But again, on the models, I like to show circulation. I like to give a little bit of emotion as to what would be happening in this space. Next slide. But what we ended up coming to as a conclusion for the group was that we would take this new student wing, efficient, super efficient student wing. It was not hard to be more efficient than the 1970s building. We pushed it 30 feet forward. We gave ourselves, so this is 13th. We decided on giving ourselves a plaza, a student street, we're calling it. So we have the street, then we have a student street where I can imagine in summer where they'll put tents out there. The bike program is located on the ground floor. They'll have all their bikes out there. It's a place where I think where you bring what's happening down here, some of the markets that go on, and I think it'll continue right under the face of the new student union. What we have on the back is that south-facing triple height, mostly glass. We'll talk about that in a little bit. And we've increased the south lawn by, this is bigger than a football field, the south lawn now. And it's fairly simple architecturally, and that was done on purpose. The user group wanted it to be flat, not a lot of trees in that space because they want to be able to have graduation there. They want to have ceremonies there. So there's a reason why it is fairly simplistic in the back. Next slide. This idea of the south lawn and this accessible building is this is right about the time when we said, okay, currently there's a basement and then there's a ground floor. And so what we would like to do is turn the basement into the ground floor so that this south lawn now, everyone can come off the south lawn and walk right into the building. That was there was a lot of feats that had to happen to make that work, but if we go to the next slide. So this is just a figure ground of the current basement of the 1950s building. And the reason I call it a basement is because there's very large blocks of program, tiny little hallways to get to this program, and that's where the student unions are located. You go down a CMU-lined hallway, and they're behind closed doors. And so, next slide. This is what we propose for the ground floor now in the new building. What can we do to really open it up? And what we did is we took some of the more underused space and we tried to interject program, and I'll go through the program here in a second of what could be in these spaces, but really it was more the idea of, at the time, I didn't know exactly what we would do to make this happen or why, but what we wanted to do was really open up this building and have all of it now. So 440 is basically ground level. So now everywhere in the building you can come in at 440 throughout the building. This is a floor plan of the ground floor. Phase 1 is what we're doing right now. It was great to go see them. They're taking it apart. And before we can build the new student wing, we have to take the Craft Center, which is actually the #2 in the nation Craft Center. We can't let it, I was impressed. We toured a lot of Craft Centers. This is a very impressive Craft Center. So we want it to be able to function, run. So it's going to continue to run while we build them a new Craft Center in the ground floor of the 1950s wing. It's very easily said, but then to put basically a shop in the ground floor of the 1950s building took a lot of effort, but we were able to figure it out. So phase 1 will be constructing the Craft Center. Next. After that, what we're going to start doing is we said we're going to punch a couple of holes into this, and what we're going to do is have communicating stairs. So now from ground floor up to the food, we have a grand stair with skylights above, which will bring light down. We've also said, okay, well, let's take this historic landing, historic entry to the building, and let's express that in the building. So we're going to have a grand stair that you come in off the ground floor, come up these grand stairs to the ground floor. Now, with that space that used to be sort of the dead stars, the center of the building, we've coined this the O Lounge. It's where it's going to be a lounge space for the students. It's one of the only places in the building where we have the O, but we actually have a giant O on the ceiling that'll be very hard to read. It won't be blatantly in your face, but we've done a lot to sort of invigorate this space. And then off of that, this was back and forth and back and forth. It took over a year to come to the conclusion, but we are going to have a pub in the student union.
Big round of applause.
Yeah, nationwide universities went to this trend of let's get drinking off of campus, and then they realized that students would drink off campus and then drive back to campus. So now they're saying, okay, let's reasonable, let's be responsible drinking on campus. So we are going to have a pub on the ground floor. And again, it was one of the spaces that we couldn't bring a lot of light to because of the fact that this is underground here. So I think it really utilizes the space well. Then we're going to build this new student wing. Like I said, we shifted it 30 feet up, so now we can bring all the ground floor of this will be, this is the one spot again where we use a little bit more glass. It is storefront. And the reason that you have a storefront is psychological. We want people to see in, we want people to see out, we want to really highlight the uses that are in this space. And then some of those uses are bike center, ASUO, sustainability, and what else? There's one more. Resource. A lot of student activity on the ground floor. And that will all be connected, next slide, with this atrium. South-facing, 3 stories, 2 stories, with a new entry on 13th, and then a very light touch off of the existing. Right now you go under. What we're saying is just maybe just plate glass. You come in. It's set up to where you can have a vestibule, so there'll be 2 layers of stairs. You'll come into a slightly compressed space as you walk under, and then you'll open up into this new student street. And we'll show you some images of that in here in a minute. So all together, this is sort of the new ground floor of the student union. North facade. I wanted to hit you with a rendering before we even went into the analysis of it, but this again, this is a rendering. It's very close to the final of what we're at, and we're going to talk a little bit about how we got there. That's this idea of new. We wanted it to be of today, but at the same time, we wanted it to be one cohesive building. And so how we did that was through a lot of analysis. We started off with just basically what was this existing 1950s building? How did it connect? What were the different volumes? What were the different massings? And how can we start to, what we saw was that it really culminated around the center of this building, and then it sort of reached out in the landscape. I think it wanted to, there wasn't a whole lot of program at first, so I think it purposely sort of stretched itself out to be a little bit more commanding on site. We looked at different rhythms of the current openings around the 1950s, and how can we start to use that same rhythm on our new student wing. Again, top, middle, and base. Very important to have a top, middle, and base. We wanted to show some ways that they did it on the 1950s building with this almost arcade middle, and then they had a very thin, which is a little different than the rest of the campus. It was very thin, almost blade-like top. And so we said, how can we do some of that same moves on our new student wing? And then there were a couple areas on the 1950s building that had, this is one of the only buildings on campus that actually has limestone. And so we are saying maybe in some of the areas we're going to actually use real limestone on our building. And they would group these large groups of openings together to sort of say, there's something here, special spaces. So we said maybe in our one spot that we used to have a performance hall, we don't have a performance hall anymore, but we do have a multi-function space. And in that space, there are going to be performances. And so maybe there's something special that happens here, and it's of higher quality material. And then lastly, we overlaid the program on it. We know that ground floor will probably always stay the programs they are, or very similar to those programs, and then maybe the middle 2 floors, we could program them more as office space, because they will be student functions, but the student unions, they fluctuate from size. They want to be able to, a single office might grow or might shrink, so we want to keep the top 2 floors more office-like, and then that special space.
So just like we did with the building massing, as Walker and his team was developing the overall strategy for the building elevations, we're also providing sustainability metrics. Now, how many of you know that Oregon Code mandates 30% glass? It does. You can get around it through different ways of modeling, but actually per Oregon Code, you should be starting out at 30% glass. And so we took that as literal. How can we do the best building possible?
She took it and made me.
At 30% glass, at the same time, we're going to meet our daylighting metric, which was a 50% daylight autonomy for at least 75% of the spaces, which means at least 50% of the time you have usable daylight in those particular spaces. So what we did was this analysis, and the base case is over on the left side of the screen. First, if I just put my 30% glazing for the absolute best for daylight, I'd put it all at the top of the space, close to the ceiling, so I could get that daylight deep into the space. But boy, that would be kind of a crappy building to be in, because you wouldn't be able to see out. So then we said, well, if I was to orient it for view, where would I put it? Well, I'd put it in that band that's between about 3 foot and maybe 9 feet. And you know what? Doesn't do so good for daylighting. all you can see all of those red lines are closely grouped, which means you have a pretty high contrast ratio. And then what if we maximize daylighting for view in? Maybe we do a vertical slot of windows. And then we said, okay, well, how could we rearrange that same 30% glass in different patterns that take advantage of daylight view and view in, and come up with a methodology to sort of then analyze them. And we're looking at not only are they meeting the overall luminance criteria that I talked about, this 50% daylight autonomy, but also looking at the contrast ratio. How even is the light? Because really what daylight suffers from is if you see it's too bright at one side of the room, you know it feels too dim on the other side. It's not that you don't have enough light. Probably is plenty fine. But if it's too much contrast, then you're going to feel like that space is dark. And so we essentially set 10:1 as our contrast ratio maximum and said these three schemes all meet that 10:1 contrast ratio from the front to back distance. And so, Walker, any one of those, I'm fine with it.
Just do that, you're done. Want to keep going? Or?
Oh, and so really what this looks at is how we're going about doing the metrics. We actually use a program that's called Diva, and it has a plugin that we've developed, a customized piece of software using Grasshopper that allows us then to quickly get these metrics so that Walker doesn't have to wait 2 weeks till I run all these metrics. They basically can be run overnight.
Yeah, one day. Go back just real quick.
Sorry.
So these were just sketches. Like we said, I did 15, 20 of them. They were all just sort of ideas. They weren't meant to be exactly what was going to happen, but what it did is it gave me a really good baseline to then start working them into the elevations. And I'm also very big on, I know the daylighting, I know the metrics, I know the numbers, but I'm also very big on visual, on how I'm going to feel inside that space. Again, I want to go back to that feeling of inside that space. So I wanted to take some of these arrangements of windows and just generically, quickly, again, all this stuff is quickly and not precious so that we could bring it back to the user group and have them weigh in on it on a weekly basis. This was turned around every week. And so this was the idea of 30% glass and more of that L-shaped configuration of what it would look like inside of a space and what it would look like on the elevation. Again, that same amount of glass on the outside, exactly what it could look like for us. And then we take 30% glass and we said, okay, well, what if we break it up? And what that could look like inside and what it could look like on the outside. And maybe some of these spot spaces where we have more of that high window, that L configuration, I think that you would use those in areas where you're not right up next to the wall and it's more trying to drive that light in. But then maybe in areas that were more loungy areas, we would do more of this larger extensions of glass. I wanted to see, okay, well, I like my floor-to-ceiling glass. I do a lot of floor-to-ceiling glass. So what would that look like in the space? But, when I'm looking at it from the inside, to me, it wasn't as powerful. Okay, well, yeah, you do have floor-to-ceiling glass, but 30% of it inside of a space, you're giving you a lot of blank wall. So right there sort of convinced me that we are only going to do this floor-to-ceiling glass in very special locations in the building. And we actually kept it very minimal when we do that. Again, what it looked like on the outside. So this is that overall, the north facade. You could see that we used in areas where we are going to be right up next to the windows. We tried to do that configuration of sort of the two side by side. And then areas that were more office space that you're trying to drive that light in, we have it L-shaped. And it's a little hard to tell in the renderings because the metal panel creates the L shape in it. And this is, quickly, I love this view, just showing that new street of, you can imagine tents out here, bike parking along the entire length of the building. South elevation, same thing. I was really hesitant about the south elevation. I can't stress how much I was hesitant about the south elevation, having this 3-story tall atrium space that, in my mind, obviously had to be all glass. It's an atrium. And so through a lot of studying, we figured out how to break down the percentages. But again, overall, we wanted it to feel like it was of the same building, had a lot of the same characteristics of the building. So we did all the same studies, showed how the volumes connected, talked about, next slide, talked about that rhythm, a lot about sort of some big punches on that south face right now where the eating is. They have that big south punch, so that was a big driver for maybe we do some of these more punch openings in the brick, top, middle, and base. Again, very thin lines of tops, so that's what we wanted to bring into our building. And some areas, that historic entry that's on the backside, limestone, real limestone surrounds. So maybe in areas where you're going to interact with this building, where you're going to pass through it, where you're going to be able to come up and touch it, that we would use real limestone in some areas. And again, programming, we wanted to overlay it. But what I think was really important for the south elevation was the fact that that program is going to be 25 feet back from the wall. And so that really needs to inform where we put these windows, because we're trying to drive that light into the student spaces. So we looked at it. Option one, I can't remember what percentage glass is, 78. So about 80% glass. We said, well, what if we looked at this and we just, you can see that when we had 80% glass, we had to also incorporate a lot of horizontal louvers into it. But here it is. This is 80% glass. And more importantly, next slide, this is what 80% glass looks like on the inside. Love it. Sold. Boom. Let's do it. But we can't do it because we need to keep our percentages down. So, okay, how can we still have that feeling? Well, let's go down to, I think this is about 60% glass. And what we did is we said, okay, these were metal panels in option one. Now we're going to start to incorporate some brick for the option two. It thickens up a wall. Again, inside. This one I actually wasn't so thrilled about. I thought that it started to feel a little too claustrophobic inside. So option three was, let's go to this idea of punches. And I think we got down to about 50% glass, 48% glass. So overall, the building is 30% glass. On the south elevation, it is 50% glass. That's as low as I could go. It was 48% glass. And what we did was we strategically placed punches where they relate to the program beyond. And if we go to the next slide, on the interior, you know what? I felt like this is, the user group, we all felt like this is pretty good. This, even though it's only 48% glass, it feels very open on the inside and relates very well to some of the big moves that we're doing on the inside.
So in addition to, of course, thinking about daylighting, which you can see the clear story that's along the top, which is next to a 3-foot deep sill, that's really the thickness of the wall that allows that daylight to bounce onto the window. We're also thinking about passive solar gain and how we can use the concrete slab to increase in terms of the heating season. Now, this is the space we're talking about for the cooling season, where we are having those 85 hours of the year that are potentially above our target temperature. And so we're right now looking at incorporating a radiant system in the slab of the this main floor to help to drive down that, which would still incorporate some passive strategies, as well as incorporating fans and natural ventilation. Similarly, we did a daylight analysis of the overall atrium space. When we first started, we said, well, how could we achieve daylighting on the south side of the student bar through this atrium space? And we looked at skylights and we looked at clear stories. And of course, skylights also bring with them excessive heat gain in the summer because of the high angle sun. So we were trying to figure out ways to improve the overall clear stories to arrive at a scheme that would achieve essentially everywhere where you're seeing the yellow is the daylight that's essentially useful daylight beyond what we would need in terms of not having electric lights on.
A couple things about that clear story is I think that it helps to incorporate it with the existing building. Again, it really accentuates those long horizontal lines, helps to accentuate the top. And what I think was most important was the fact that we did the couch and we don't have to have skylights in this space, which saved us money, as well as, I think, visually, I think that's going to, the way, and she kind of browsed over it, but these are 3-foot thick walls. The south wall is 3 feet thick. It's doing a lot of its own shading of itself. So there's going to be some play in there, I think, of how this light shelf comes in off the top and bounces that light in.
And so here's the overall analysis of the overall elevation. So as we talked about, more glass on the south, although overall the south is really only at 32 when you start to take into account all of the sides. But of course, least elevation that you would desire glass is the west. And so we're minimizing glazing on the west, 30% on the north, the study to show, and then 36% on the east for an overall total of 31.7. One of the last things that we do in a project is to look at how the project is comparing to LEED. Now, the Oregon Model for Sustainable Design mandates that the project be able to achieve at least a LEED Gold scorecard, but we don't, in our process, focus on LEED points. You know, are you going to be able to get the bicycle parking point? Well, of course we are. It's U of O. We don't, you know, we try not to focus specifically on points because we found that that leads to point trading and doesn't really overall achieve the goals. We are currently tracking 80 points for anybody who knows. That is the threshold for platinum. So we call it LEED Gold because that's pretty narrow margin, but we're looking at some additional strategies such as a task ambient approach for our electric lighting, as well as some other things like FSC would maybe come back down the road that would allow us to achieve the LEED Platinum. But again, the goal was gold.
At this time, we didn't know about the FSC, but we have learned that, and you'll see in the renderings, that we are using FSC wood, and it is a wood structure inside. A lot of that's not an easy sell to a user group to do wood structure, only because it hasn't been done a lot. So when anything that hasn't been done a lot, it's kind of a hard sell. And so some of the ways that we would form the discussion were back to some of our original goals. Well, these were our original goals. This is what we wanted to do. And instead of just hitting someone with a rendering and saying, this is what you get, this is what it is, we much rather hit them with diagrammatic images like this, saying, you know, this is some of the stuff that we said that was important as a group, and these are some of the areas that we think are doing it, and these are some of the materials that we think could do that. Next slide.
So one of the other things that was important in our overall design process was to figure out how we can reuse the 1970s building in our new facility. And for those of you who've been there, you know there's a bunch of glue lamps that are as handrails. There's great wood in the ceiling. We've got lots of concrete, and we've got lots of glass. And so we started to think about how could we incorporate those materials in the existing building. And so as we started to frame the windows, we're cutting down the glue lamps and using those to frame the windows and provide a little warmth at the window itself. We're grinding up the concrete and being able to use that as part of our aggregate and part of the flooring. And then the overall look and feel is really to incorporate the idea of doing more with less, exposing the structure as Walker talked about, but not having a lot of additional finishes on top of the finishes that we have. So we're really trying to only augment with existing materials from the 70s building.
That was important in figuring out the cost of the wood structure, is that we had a large budget in for wood walls, wood slat ceilings, and we incorporated that into, okay, we're not going to do that, and so that helped to offset the cost of the wood structure. And lastly, after we walked through multiple iterations of more of the black and white, then we start to bring in these renderings. And again, I always stress that these renderings are quick, they're done quickly, they're not about down to the doorknob or where the toilets are. It's more, again, is this the feeling that you, the user group, want this space to have? And it was pretty much overwhelmingly yes. And we did show this rendering twice. We showed it with a concrete structure, and we showed it with the wood structure, and overwhelmingly we wanted the wood structure. This is looking back against that south wall, and these are those large pieces of glue lam that we're going to reuse that Lisa was talking about. We use that in multiple locations to frame these very large openings. And this is the new heart. This is where one thing that we did not a very good job of until they saw this rendering was understanding the idea that the historic 1950s building.
Or explaining it.
Yeah, we didn't do a very good job of explaining it, that this was actually going to be inside now. I mean, we all knew that we were coming in underneath the building, that we were going to come in through these sets of glass doors, and that then you would be into this space. But it wasn't until we showed this rendering that everyone was like, wow, there's the 1950s building.
It's now a room inside, so it provides some of the interior finish and the richness inside the student union because of the era of that particular design.
And using some of these renderings, we looked at different materials to use on the stair. We looked at options of, do we take out the historic windows? We were back and forth on that, and we decided to keep them in there. One option was to just completely get rid of them so that people could look in, but we still wanted this to be a somewhat quiet space. Another option we had was that maybe they are something that opens up when you want them to, closes when you don't. But we settled back on the fact that we're trying to do as little as possible on this historic facade.
And so, again, the same ideas as we were talking about before, where we're looking at how we can incorporate the materials from the 70s building and really create an overall look and feel that's really cohesive. Using inspiring materials, showcasing what we have, limiting finishes, making sure the finishes we have are durable, and making sure that overall it's a cohesive whole.
Just wanted to leave you again with this is a quick rendering. Everything's not absolutely figured out. We are now probably 50% through with our interiors package, so now we're much more figured out than what this rendering was, but I actually prefer showing sort of the in progress, quick renderings. This is what we showed the user group coming in historically underneath that building. You're going to come in through a low spot, and then underneath the Taylor Lounge, and then you're going to come in, and this is what you're going to see. The heart of the building, stairway up to the student bar. And I think what this shows is very clear communication of direction and a very wide open space.
We'd be happy to take questions that people have. John?
I guess I really enjoyed this presentation. The big question in my mind is I didn't hear anything about either seasonal or movable shading.
Would you mind repeating the question?
Yes, so John was asking a question about seasonal or movable shading. So we had originally incorporated an idea of a sunshade on the exterior, which Walker had showed you when we were talking about the overall exterior when we were going with the higher glass. We will have seasonal shading in terms of the interior blinds, but we could not afford under a VE any exterior shading.
Curious about the daylighting analysis of the student office wing, which looks to me quite deep north to south. So what is your approach to daylighting that big block of redesignable office space?
The incorporation of the idea of making sure that the middle zone was really where we kept things like the bathrooms and the mechanical rooms and electrical rooms and storage rooms. So we're really borrowing light from the north side and from the south side. And then we're really trying to drive the light deeper into space through the idea of light shelves and through reflecting surfaces. And that's really what we were studying with the modeling, is how can we drive that deep lighting deeper into the overall space. We had originally done an analysis, which we didn't show, but we had done an analysis of what would be the overall daylighting if we did a 60-foot bar, a 70-foot bar, and an 80-foot bar. And ultimately, we ended up with a 70-foot bar. The 60-foot bar was best for daylighting, but it really didn't fit all of the program and maintain on the east side. We needed to maintain the moon tree and make sure that that wasn't something that would be lost in this overall renovation. So ultimately, we went a little bit deeper, but looked at how we were going to drive daylight in.
That was presented to the user group. We showed them the metrics. We said, okay, optimally, we would like a 60-foot wide building, but this is some of the stuff that's going to happen if we do a 60. It's going to get longer. And another big driver was the fact that they do want to keep this space for possibly a future building. So we were limited on our length of the
Yeah, that's right. It was when we had the concert hall that we were especially in here.
A follow-up question. You said the interior development is much progressed from the renderings.
Yes.
What I guess I would be looking for is really innovative strategies of how you get more places to hang out within such a large space, because there's a lot of space in the renderings. So what are the strategies for making those large areas more inhabitable by clusters of students?
That's our presentation on Tuesday to the university, because they had the same reaction, because that's a very wide open space. And it was, you have a night to do the rendering, so we didn't put a lot of stuff in there. But now we're incorporating things like benches that are part of the architecture to break up the space. We're trying to use lighting, actually large scale, we're calling them interior street lights, to sort of create individual living rooms in that space. We're doing a lot to try to break it up as much as we can. But at the same time, they want to be able to clear it all out for an event if they can too. So when you do things like a built-in bench, we have to still figure out how flow is going to work and how they're going to have a graduation event in there with something like this in the space. It's been very challenging.
Question in the back?
Yeah, in the heart space, how is the ceiling being treated? It was hard for me to see from here. What was the surface treatment of the ceiling?
Yeah.
I really want to look at it from here.
So this actually is partly under the existing building, and so we're covering up structure. So this is a ceiling tile system. So it's a tech zone is what they call the particular product. So it's not an ACT, but it's like an ACT product, but it's larger in scale than an ACT product. And that's primarily for acoustics, but also light reflection.
And a couple of things we've done is, you don't see it here, but there's now a 15-foot gap between
it's really
the
pretty.
new and the old, which will go full scale, and you'll see the skylight up above, which I think is a beautiful space. And now we're going to see this slot.
I think you can see it. Then you can kind of see where the space is right there in that rendering. So that's a gap. If you looked up, there would be a skylight, so then you get natural light to wash the wall, the face of the existing building.
And then also, we're going to incorporate something. This is a whole design shred in itself that the university wants to go over, is the front desk, what it's going to look like, where it's going to be, and some of the lighting incorporated with it. So I do think eventually there would be something associated with the front desk that will break up that space too. We're suggesting possibly a mobile front desk, or a front desk that's actually inhabited space. Some of those things are way out there, but we are trying to push what's typical of a front desk. And that's going to be an entire design charrette with the university here soon. But we have a whole set of slides just for sort of this space. Or isn't even this space. What if it moved over and it was more incorporated, more along the south wall? We have a lot of different ideas of what that could be.
Yeah.
You're talking about using FSC lumber?
Yes.
What does that stand for? And also, what were some of the things you're thinking about when you're deciding to use it or not use it?
Forest Council Certified is what FSC stands for, and it's basically a certification process that tracks how the trees are grown and make sure that they're sustainably harvested. And so incorporating FSC would just, in essence, is the idea of making sure that the trees themselves are sustainably harvested. The question that you were asking about, how are we ensuring that it's incorporated?
Or no, like you were saying you just decided to use it. I was wondering.
Well, we have to price it. And this is the first time I've ever been able to use it, because generally the price comes back shockingly high. And for whatever reason, I don't know why, it came in.
Market driven. It's always market forces. So.
For this particular project, we'll be able to do an all wood structure, and it came out almost equal with. I said we did have to incorporate the fact that we were going to do more wood walls, more wood ceilings, so we took that money that was incorporated in it to make it zero out to be able to do a wood structure.
And one of the things when we were looking at the analysis of whether to do the wood structure or not is we used a new software program called Athena that's being developed to look at the life cycle cost analysis, really the life cycle analysis. So we're looking at a cradle-to-cradle type scenario, and what are the overall impacts, not just the immediate impacts, but also the impacts both sides. And that was something that was interesting to see, and something that Kieran Timberlake is actually developing this particular software, and it's currently in its, I think, beta version now. When we were using it, it was alpha version, so had a little bugs.
And so the wood structure was in. We knew we wanted wood structure, but we couldn't guarantee the FSC to stay on budget. So we actually had that priced
as an alternate.
As an alternate, the price came in, and now we're able to say with certainty that it is going to be an FSC certified wood structure.
So I'll take this question first.
Can you elaborate a little on what's in that 3-foot
wall. Water.
Yeah.
Two cavities.
So if we go back. So this is another thing right now that we're just showing sort of a blank wall. But what I love about the fact that now that we do have that depth to play with is I think that, and again, it wasn't done on this round of renderings, are things that we could start to incorporate into that wall, such as seating. We weren't able to get the exterior shading. It wasn't in the budget. So we're hoping, we ran a lot of numbers, that the actual depth is going to help to do some of the shading. And it's also going to then create a light shelf above to help. I'm hoping, we're still trying to figure out how to do it, that on this beautiful wood ceiling, we're not going to see a single light. Can't say that for sure yet, but I'm hoping that we could do something along this light shelf up above and possibly in these areas to project the light and just glowing wood structure at night. But yeah, I think you can start to see we have a student lounge on the 3rd floor. Same thing, we're going to turn it into seating. And it's a way, we don't have an unlimited budget, so this wall is staying fairly pristine, fairly blank, but I do think the fact that we do have that 3-foot depth, we can start to incorporate some art into that. We could do seating areas. I want to do something in this wall. I keep pushing for it, is somehow to show every student that ever graduated from the University of Oregon on this wall, somewhere, somehow, and let it continue as the years go on. I don't know how we're going to do that yet, but I think something with that depth will help us do something like that.
Then I think to answer your question, maybe technically it's a double cavity wall that has insulation on the interior face, so it's brick on the outside, and then we're looking at interior insulation in the cavity wall itself. So that was a big important driver to really drive up the overall wall insulation, put our money in the envelope where if we're essentially going to be paying back over the 40-year lifespan or longer of that particular element.
And the structure is actually, so it's all wood except for this face is steel, and there's a lot of steel in there because it's taking up the new student wing, but it's also having to incorporate, we have a big break seismically from the 1950s building, and so, and the fact that these are large punches, the structure itself got really massive and thick.
And the thermal, having the deeper wall allows us to have a true thermal break from the steel to the exterior wall. So that was another important driver for the overall. Somebody else had a question. People over there.
Are you going to be able to use any of the wood floor from the 1970s building or the furniture from that wing?
Unfortunately, not on the floor material. There was asbestos that was when that particular material was laid down. So.
It's all over in the 70s building.
Unfortunately, so that wood floor, we tested it, and we won't be able to use that particular. I know we're reusing a lot of the furniture. I can't tell you which pieces we're reusing, but the budget didn't allow for new furniture, so yes, we're reusing the existing furniture.
The only spots we have in the budget for new furniture are basically the atrium and the heart. These two spots. Everywhere else, we're reusing all the furniture from the old building.
I'm not giving up on the shading. Universities are covered with ivy, after all. And if you guys went with a Virginia creeper and the cheapest possible trellis, couldn't we at least get seasonal shading?
I didn't understand what you were talking about exterior seasonal shading. Yes, we are incorporating some exterior seasonal shading, particularly on the craft center piece, which is one that we haven't really shown you a lot of. But that was an idea of having a trellis along that particular side with the vines that would grow up so that we could start to incorporate that overall shading.
And what about this great big south facade?
I'm going to let Walker talk about that one. We've gone back and forth.
We've gone back and forth, and I'm really pushing to not have to mechanically cool this space. So I think it might come back into play because originally we were VE'd out, can't do it. But now that I think we are literally on the cusp. Some people don't want to do it, some people want to do it, and I think maybe we could take half the money that we would save and we could do some sort of shading on the exterior.
So, as you can see, this is a topic that's very relevant to our
As
overall
of today,
design conversation.
we're still talking about this, so I would love to not have to mechanically. I'd love to just be able to vent this in the summer. So it's back on the plate.
Thank you very much.
Yes, well, I hope you enjoyed. We really wanted to show you our process.
Yeah, well,